All right, how's everyone doing? Good, yeah? So the structure for this session is a little bit different. So we sort of titled this Innovations in FHIR Data Management. And really what we want to do here is cover two very different customer use cases. These are customers that have been using InterSystems Iris for Health and our FHIR server. And yeah, we're just very excited to sort of share some of the very unique use cases we're seeing here. We're going to start off with Stanford Healthcare and the data science team that have joined us for their first Ready Summit experience. So yeah, they're going to talk to us first a little bit about how they've built their clinical workflows and some of the decision engines that are built directly for the FHIR server. And then after that, we're going to have two speakers discuss Méderi Hospital and what they've been doing, integrating with patient indexes and doing merges and matches. So yeah, I'll hand it over to Stanford team.
Okay. Yeah, I'm Kevin Kindschuh. I'm a sales engineer, and I've been working with Stanford University over a number of ways since they installed their system, I think, over 10 years ago, and have been a longtime customer for integration. And so there was a time when I came to one of the meetings with the integration team, and somebody from the AI team came in and said, we've decided we're going to standardize on FHIR for all the data and the schemas that we're going to use, and to take some of the AI and machine learning work that they've been doing in the clinical workflows up to the next level. And they said, we've been having some things that have been a block for us. One thing, getting the whole wide range of data as fast as they wanted was not happening. Some of the data was causing duplication, and they're trying to figure out how do we deal with duplication. There were some pieces of data that were missing, some of the image data and test data that they really needed to make the AI very effective. So we started going through the process of saying, how can we do something with them using our FHIR repository technology within Iris for Health? And so you can see here's a couple of the issues that we took as our challenge during those early meetings. They wanted to be able to take data very quickly in real time as a response to transitions of care or a result that's delivered or those sorts of things, and refresh that data very, very quickly. And in order to give real-time responses at the same time, they wanted to absorb large amounts of bulk data to do their translation and training of all their AI data. And so how did we do both of those things, dealing with those different factors? So on the next slide, you'll see that we came back and said, well, we've got a number of ways we can pull data in. We can pull in all different forms of data at different ways with all the connection points we have. We can orchestrate that data. We can transform it into FHIR. We can use this for triggers to make that happen, and all those sorts of things. And so we had this nice set of building blocks that we were going to use to see how we could put this together. And initially we thought, well, CCDA documents are going to be the fastest way to get the large amount of data through, but that had kind of evolved, and we found out that we were doing things a little differently. So we got to the point then when we really started diving into experimenting with this combination of technologies. And a couple really interesting things happened along the way that caused us to really speed this up, get some amazing performance, enhance the set of data that was available, tuned both for pulling it from the EMR as well as absorbing it in and passing it on down to the AI processing that was to follow. And so my friends here are going to take you through some of the steps of the result of that, first with the head of data science, Nikesh, that is going to talk about some of the larger initiatives that this was supporting within their organization. Then we're going to get into the weeds a little bit about how this was implemented. So I think you're going to enjoy this road that we went through together.
Thanks, Kevin. So I think we'll play the thing. So you got Kevin's viewpoint on kind of how he saw it. Now you'll hear my viewpoint about that same conversations that we were kind of having as we go through. And then Krishna will actually tell us what actually happened when we thought about it, right? So we've been thinking a lot about a variety of different problems that were coming to us from our physicians, from our nurses, from a lot of our operational stakeholders at the health system. One of the ones that really kind of got us thinking and asking some of the questions we were asking Kevin and others was really this piece around our capacity constraints. So our hospital was under capacity constraints. We were seeing a lot of people boarding in our ER. Census was high. And we had just kind of, through some marketplace developments and partnerships, actually had access to another ward, actually in a different hospital, but we had kind of branded it as Stanford, and there was a place where we could actually send some patients who, if they were appropriate, for advanced care or for additional care. And the question became, how do we figure out which patients we can send there? And the process that was going on, you guys can imagine this. There's ER is overflowing. They have about lots and lots of notes to kind of go through. And the clinical teams are just trying to figure out, okay, how do I kind of very quickly figure this out and what's going to be there? And the unit was called Sequoia. So it was about, hey, how do I transfer these patients to Sequoia? Are they eligible for Sequoia? And so we've spent some time from the AI perspective, say, hey, maybe there's a there. Can we actually address this question using language models? And turned out we could. So we were doing pretty well in terms of being able to ask them the questions that they were looking through their unstructured notes. We thought a lot about evaluation. We thought a lot about like citations. How's that going to work? And we said, hey, there's something here. It started kind of a group of projects we're doing, which we were calling part of our chat EHR efforts as we go through. So this HR platform that I'm going to kind of just highlight very briefly really was there to say, hey, there's a slew of problems that language models can help you address. If we can get to the right data sources, and we don't think about just one language model, there's a variety of different language models that you want to kind of bring in, there's probably ways to kind of automate some of these use cases we're seeing. How can we actually enable that? A key requirement to do that, though, was to be able to kind of get data in a timely and a complete way. So as you guys know, not everything is going to be available through our clarity tables, especially if I'm thinking about a patient that's sitting in an ER. How do I get most up-to-date information and make that available in a particular place? So our initial efforts to do this, as Kevin pointed out, we decided, hey, let's use FHIR. What can we do? We have our chat EHR talking to our EHR. And we ran into a variety of different challenges, right? So fragmented access. It was taking a while to be able to kind of get that. I couldn't get everything in one call. And again, from a language model perspective, it was one of our first use cases where we actually wanted all of the information, unlike our additional prior FHIR use cases. Processing delays. So if these queries are going to take us, hours to run, no clinician's ever going to kind of use it. And if I need to kind of get a census report done pretty quickly, how am I going to think about that from that perspective, right? And then finally, multiple data sources. So as we think about the data, where is it coming from? If I need additional information, how am I going to be able to kind of bring that in as we go along? All right, that's all you, Krishna.
So let's talk about, again, I think as you mentioned, right? So our current AI applications are already doing this data transfer. They're able to query EHR, and then they were able to get, of course, all the data they need, right? They were able to issue a bunch of async API calls, get, of course, individual pieces of data from EHR as they needed, right? So we want to overcome, some of the limitations that are out there, right? So we are introducing a new platform. It is called Axiom. So let's talk about what is Axiom first of all, and then we will talk about what are the performance improvements we have gained over the time using this new platform, right? So it is our innovative solutions. Obviously it has a very fancy acronym, right? But it actually stands for advanced extraction for intelligent orchestration and medical insight. In an essence, Axiom is nothing but it is built on InterSystems IRIS for Health. It is fueled by the system. It is our new unified file repository. It is mainly designed to challenge. It is mainly designed to tackle the challenges of fragmented healthcare data, of course, and also mainly to overcome some of the limitations we have with our EHR systems, right? It consolidates clinical and non-clinical data from multiple data sources, and it has a potential to present that a unified patient view in real time, everything, of course, in FHIR format, right? So, so let's talk about how the data gets entered into this platform, into this Axiom platform, right? So, obviously, for every we have many triggering events, maybe a hospital admission have happened, we receive that ADT notification, via the integration engines, right? or maybe there is a ED walk-in, or maybe there is a scheduling appointment that have happened, or maybe the user, some kind of clinician have taken some kind of action in the EHR system, maybe they have placed a new order, or maybe they have opened one of our AI-based applications, right? So as soon as the trigger happens, what Axiom does is it downloads all the encounter CCDs using FHIR document reference. And once it has, once it has all those encounter CCDs, right, it sends them through a or CCD pipeline where the data, the CCD data gets transformed into SDA, and then eventually the SDA data gets transformed into FHIR resources. Again, maybe some of us are already in the previous call with Elijah, on the FHIR transformations, right? So in our case, even though there are some other options available, right? Maybe doing the dynamic object or dynamic array, or maybe doing that FHIR resources, right? So we mainly took this SDA approach because we have data coming in through multiple different data sources, right? We have data coming, via CCDs, and then we also have data coming in via, HL7 events, and maybe even through FHIR, right? So mainly we took that SDA approach because, we wanted to have that, the unified transformation layer. That way, we can standardize all the data that is coming in, even though we are getting multiple data, right? We are able to standardize everything and expose that as a FHIR resources. Axiom downloads all the prior data using CCDs, but it doesn't just stop there, right? It is also continuously listening to all the real-time updates that are happening on that patient's chart. Things like there may be a new encounter updates, or maybe a new notes have been entered on that patient's chart, or maybe new results are being entered on that patient's chart, right? So it also continuously listens to those events via our existing integration engines, right? And it also converts them as the same way, HL7 gets transformed to SDA, and then eventually SDA gets transformed into FHIR resources. So, so that is how we are able to have that unified platform, and the data is always stay up to date. So now let's walk about one single patient data access, without Axiom and with Axiom, right? Obviously, before Axiom, right, as I mentioned before, the systems have to issue a bunch of, async API calls. I think everybody knows about FHIR, right? So they'll have to find out, based on the patient medical record number, they will have to find out the patient FHIR ID. And once they have the patient FHIR ID, they will have to, send, separate API calls to the EHR system to, for example, to get the medications, or to get the procedures, or to get the clinical notes, right, and so on. And again, the people that have dealt well with FHIR, right, they will have to deal with all the pagination for sure, right? And even when it comes to binaries, right, especially because a lot of the use cases we are currently dealing with, it has something to do with clinical notes. And since these notes are definitely not exposed in the same resource, they will have to issue a separate binary call, to get those clinical notes. Or if that content is available in a PDF or maybe a different image, obviously these applications have to issue that separate binary call to get all the data. So as we can imagine, right, the time just adds up. Even though these are being made in an async manner, right? Still they will have to wait for that, one call that takes a long time, to really wait for that, and then eventually do all the aggregation and then filtration that is needed to get that in place, right? So in this particular example we are looking at, it took almost around 2 minutes, right, to have that patient data available for our AI application to make some execution logic on that. Definitely it is just enough the time to think that the system have been frozen, right? So, and now the same use case, the same patient example, we are able to run the same patient using the new approach. Again, obviously they will have to find out the patient FHIR ID. That probably take half a second, right? But once they have the patient FHIR ID, using our unified FHIR repository, they're able to get all the patient clinical data in one single dollar everything, right? They don't have to make those recursive calls to the EHR system or to a different place. And that's including even binaries, because we are able to even expose all the binary content as an inline of the resource itself. So they don't have to make any separate calls, for binaries. And we can see the difference, right? Like, now, they have all the data they need in just, in just a few seconds, right? So we looked at, one patient example, but let's also zoom it out a little bit more, right? So as part of a POC we have done before even getting to the actual implementation phase, right? We took a random a different randomly selected 25 patient population. For that patient population, when we ran the comparison, without Axiom and with Axiom, right? We have seen a huge improvement on an average, right? On an average, we have seen a 8 times faster query response times. And there is one patient in there, again, we are an academic medical center, we have a lot of patients with a lot of heavy chart, right? With a lot of sick patients, right? So that particular patient, we have seen a huge difference in the query time. That is almost 21 times faster than whatever the approach, the without Axiom approach. Yeah. So on an average, right? Overall, with Axiom, we have delivered an 87% baseline improvement in data processing efficiencies. If Axiom were record, definitely it will be in a fast lane, right? So one thing that I wanted to mention, again, going back to the data journey, maybe, right? So we didn't have that secret sauce right on day one, obviously, right? So we definitely went through multiple hiccups down the road. We explored EHR's capabilities to see maybe the EHR will support some dollar export or maybe some other ways where we can get all the data we need in one single call. But obviously EHR has their own limitations. And we also looked into the CCDs. Maybe we can get all the data we need in one single patient summary or clinical summary CCDs. And we came to know even those CCDs will only contain typically the last 3 months of worth of results or last 3 months worth of encounters, right? So we went through again that whole hiccups and loops to find out hey, okay, we tried this is not going to work, and then we export something else, and then eventually we landed into this into that particular data journey of downloading data using encounter CCDs and depending on HLs and V2s for all the real-time updates. So finally, let's discuss how Axiom integrates with our with our AA platform, which is ChartEHR, right? ChartEHR is our AA-based application, and it leverages large language data models to streamline clinician workflows, such as Nikesh mentioned before, right? For example, assessing patients' eligibility for transfer to our Sequoia, or maybe determining patients' eligibility for hospice, right? So by combining Axiom's rapid unified data access with ChartEHR's LLM-enabled functionality, clinicians now gain a comprehensive 360-degree view of the patient in real time. Together, Axiom and ChartEHR forms a powerful partnership together, just like two pieces of puzzle, just coming and fitting together, right? Yeah. So now let me hand it over to Nikesh to talk more about our new ChartEHR and Axiom automations.
So, I think hopefully, I think this audience probably appreciates this much more than anyone else, but it's really, it was really dramatic to be able to kind of get to this, especially as we were thinking about, how do we think through the sets of use cases we're kind of getting in, coming out. And, huge kudos to the team to actually really enable this. And kind of just to wrap up in terms of where we ended up. So what we're now able to do is not just have kind of this platform that really enables this in a timely way. We actually got our Sequoia use case out. So it's in active production use where we can actually use language models to kind of better assess eligibility for transfer to this particular unit. There are other similar use cases now we're kind of putting in place and implementing. On top of that, the fact that we could get to this in a low latency way also enabled us to build a UI that is now available within our EHR for our doctors to be able to kind of work with for their particular patient, a variety of different language models and be able to actually use them. And so that's been pretty exciting. That actually just came out a couple of weeks ago, and we've been kind of slowly rolling it out to folks as we go through. So again, thank you for listening to us. This is no small feat from a variety of different people who I've all listed over here, really both our data science and our integration teams really coming together to be able to kind of make this work possible, along with sponsorship from our leaders, Nigam Shah, Anurang Rebri, and Mike Pfeffer. That's our contact info, and thank you very much for listening.
Thank you guys, that was fantastic. So we do have time for a few questions for the Stanford team. So if anyone would like to ask, now's the time. Yep.
So I would make up that as you guys were developing this, there was a deduplication kind of processes you had to go through. Could you talk a little bit about like maybe some of the challenges you had there? And does the Axiom piece maybe take care of that, or is there other pieces that you do for, because I know some of the challenges we've talked about was one, a call out with FHIR, bringing that back in. One, EHRs don't do it, which is, I know they keep saying we're working on it, which is probably why you did what you did. Secondly is the deduplication piece, right? Bringing in data that's probably been already sent somewhere and then coming back. So if you could give me just a minute, like what maybe you guys did there.
Yeah, sure. I think maybe Kevin already knows this, but yeah, like we definitely encounter the deduplication problem, right? Definitely as we are, for example, maybe the same patient comes again, because we have already loaded the patient, but if you are bringing in the C series again, the deduplication problem definitely exists. But again, one of the things we have done to overcome that, right? So luckily we are, we have only one EHR system, so we already know that the order numbers or the patient medical record numbers that we are getting are definitely unique by the nature, right? So, so what we have done is, we have worked on that accessibility mappings, to be able to grab those unique numbers to make sure that those numbers do exist in SDAs. And once they are in SDAs, obviously, InterSystems Iris for Health, has that override methods, which we can use to differently to override the behavior, whatever it does. Like by default, it always creates a new GUI ID, right? But we are able to override that method to bring in that unique number and then save it as a FHIR ID. So even though we are processing the same CCD again and again, it will still make sure that we are not creating duplicate resources. That is definitely one of the learnings we went through differently. Yeah, it's still again we have actually a couple of people already working on that. Additional resources that we are currently working on. Yeah.
Can I just add just a point to that? Because so what we ended up doing is allowing the EMR to be the identifier of all the resources, and then when we store the resources, we use a put rather than a post, and then we use those identifiers. We had to extend actually the length of the identifiers because the EMR gives longer ones than the standard allows, but we could adapt that in the FHIR to do that. So that meant that we kind of, by managing the identifiers very carefully, we were able to eliminate that deduplication problem, because that gives us a single identity, which is not quite the way that the FHIR repositories usually work.
No. First, awesome work. Congrats. I think this is great. I have a couple of questions. The first one is, as far as I understand, when the chat EHR is someone is working on it, it's not talking directly to the EHR, but with the FHIR server. Is that correct? Through the Axiom stuff. So you actually don't disturb the electronic medical record with requests. You're just using the FHIR server as a facade to. That's okay. That's good. That's one of the things there was. The other thing is, I was going to the direction of the deduplication as well, because I think this is important. So have you thought when you started, because I think the next presentation, we're going to talk about a little bit of this with the use of the MPI in front of it. Like, hey, there's a new person coming, this person exists, doesn't exist, or yes, exists, but the MRN is different. So maybe someone will say, okay, now Daniel has 2 IDs. So the second time someone asks about Daniel, I will actually get all the IDs that are related to Daniel and query with all these IDs and get a bigger bundle. Have you guys thought about that? Or in the end, you didn't need it because you have one MRN because you're using Epic for everything? Can you?
Yeah, we definitely thought about, like, again, even though we are using, one single EHR, like, we still have that, like, like sometimes, the patient merges happen, right? We receive 8 notifications, right? That is definitely one of the things we have actually in pipeline to deal with, like, how do we make sure, we have the logic to look up the patient, right? So whenever the 18 comes, right, like, we have a previous medical record number and we have the new medical record number, right? So we are looking up the patient using the old medical record number and then, replacing that resources, using that new medical record number. We haven't fully implemented though, like that solution, but when I saw that the next presentation, I'm actually really excited to hear what they have to say on that. Yeah.
Okay, thank you guys. That was great. We don't have time for questions before the next session, but yeah, thanks again, Stanford team, and let's hear from Méderi. So if you stick around, we're now going to have a sort of 10 to 15 minute presentation from the Méderi team, who are going to be talking about patient matching and merging, all built natively within FHIR. So,
we are Matías and Bernardo. I am a tech lead of the Chile office. And now we are talking about a user case of FHIR implemented in Colombia. So thank you for coming. So let's start, please, Mati. So, well, who is Méderi? Méderi is a big player at the like a clinical provider in Colombia, in Bogotá. The headquarters is in Bogotá. Actually, they are a high complexity clinical providers. More than 800 inpatient and ICU beds, and their specialties is oncology, internal medicine, and neurology. Please, Mati. Actually, they are recognized like the second best equipment hospital at Bogotá to admit patients in general. They attend 3,000 people daily. And in the pandemic, they start a few initiatives like real-time data feed by medical robotics and other devices, and telehealth to follow up the patients. No, that's it. Please. So that happened in Latin America, in the Latin region. So the trigger to start to innovate, no, based on the evolution of the implementation, start like a Colombia Joint Resolution, A66, and that rules how the all providers in Colombia share information, clinical information, and data demographics. And that's so Méderi start a healthy data initiative based at this data set, no, ruled by the health minister. So they want to promote the continuity of the operation, the operational efficiency and reporting, and in the future implement a clinical decision support. That's it. And well, what was the Méderi strategy? They want a CDR project. So in this case, a clinical data repository based actually in FHIR. So the principal components of the CDR was an MB to unify the patient data, the support to CDS hooks, and actually the FHIR interaction and operations, and a very important part of communicate with the data sources via ESB platform. That was the approach, what they want at the moment. So please continue. And what was our proposal to solve this CDR repository? So if we see now, it's simple, but at the time was a bit difficult to thinking about that. But actually, we use Iris for Health and Health to communicate with the old data sources, and actually the custom logic to recognize the identifiers and when is different the FHIR resource is solved by Iris for Health. The FHIR server only persists. That is good for that. Persist the information and querying the information, no more than this. And the patient index is the responsible to unify the information. So if in this case, so in simple words, for example, if a person have or a patient have information on 3 data sources of Méderi, there are 3 different patient resources persist at the FHIR server. So when you query or consultant over this patient, the MPI has the capability to find these resources and make only one to show you. That's it. No? And actually the other user final user case was implemented by the other solution of the HealthShare family products. That was the idea. So, well, now simple, but we take a time to resolve that, to try to resolve that. So, so Matías, part of my team, show you a demo of this implementation.
Thanks. So, as we're doing this demo, I wanted to showcase primarily the FHIR interaction with the MPI and how we use that to solve the data application, the identity matching, and the data enrichment using like the FHIR resources and inserting them into the MPI engine. So, this demo is going to work this way. First, we're going to submit some patients coming from different assigning authorities to our FHIR repo, and then we are going to use the identifiers, so the IDs coming from each patient resource, and insert them into the MPI, and use them like as a kind of additional identifier in order for the MPI to do this matching, and then work on this match operation between the FHIR repository and the MPI. So I'm just going to go straight to the demo. Yeah. So here I got this patient, just a random patient. So we got this random patient which got the medical record number value, this one. It's got a default assigning authority, OID, and the identifier type being the medical record number. So we're going to post this resource into the FHIR repo. We got that these patients had the FHIR ID 102. And so now we're going to post another patient, but that's actually referring to the same real life person. But in this case, it's got another assigning authority and another medical record number. So we're going to post that as well. We know that these 2 patient resources are referring to the same real-life person, but we don't know if they are linked to each other or how we can link them to each other. So that's why we use the MPI. So now I'm going to show the patient search. Okay. I'm going to search for the MRN that we already published. I think it was number 13. And here we go. It's Lionel Messi. So I'm going to go to the whole record viewer, and I got the possibility to link these two patients and merge them into only one register. I'm going to update. So that's it. Now that the linkage was successful, I know that, for example, this patient that has different assigning authorities, default AAOID and default AAOID2, already has an additional identifier for each FHIR resource, in this case 102 and 103. But I want that to be visible in the FHIR repository. Hence why we do this match operation. I have the 102 patient, and I'm going to do a match. Now I get these two resources that are now linked to each other. We can see that because now I'm going to do a get operation on the patient 103. Let's do it like this. Yeah. So if I look now for a field called link, I can see that this patient is also linked to the patient with the ID 102. That way, we don't necessarily have to change or update the patient information in the FHIR resource, because we want to have the original data source and we don't want to change it. We just want to link that to all other data sources referring to the same patient. So now, for example, I can, so now that I have them two linked, I can access all the information coming from these two data sources. And for example, if the patient with the ID 102 has 10, for example, medication statements linked to it, and the patient with the FHIR ID 103 has 15, I can use everything query to get them too. So just do something like this. Check my query. I'll say ID. That way, I get these two resources that are referring to the same real-life person. For this demo, we didn't add any more resources, but if we did, we, for example, could do something like everything. We should do something like this, and we can get all the resources that were linked to this patient. And that way, unify the data so that it can be visible for anything you need FHIR related. So, I also wanted to talk about how we solved the deduplication problem. We didn't work with any, we did like a custom solution. And that solution was done doing a separate table that wasn't linked to the FHIR repository itself, but it kept the registry of every identifier that we added for a patient. For example, here I'm filtering for the resource type patient, and we did this tuple that consisted on the identifier type, in this case the medical record number or the social security number, and the identifier value that was a combination between the assigning authority and the value. That way we got different FHIR resources so that each patient resource represented an instance of a person in a healthcare facility, and we were able to identify and make it like an individual record without having to merge them or without having to change anything of that patient. That's the demo for today. We want to talk about also the next steps. The first one will be to do a platform migration to, for example, Amazon Web Services, so that we can offer this product to everyone who will need it. The other step, we'll do an integration with the EPS, the health plans and players, using the FHIR repository, and integration with other government entities. For example, in the case of Méderi, the hospital that we did this solution, la Secretaría Distrital de Salud de Bogotá, which is like for the Health Ministry of Colombia, they wanted to apply this FHIR repository for all the healthcare facilities in Colombia. And now, with what we have here, we can send them information of every patient instance that we have and submit that information to that repository. So that will be it. Thank you very much.